I'm Dave Kassler, amateur radio call sign KE0OG, and welcome to episode number 71 of Ask Dave. Today is a review of another antenna. Now, this antenna is called the Cobweb antenna. It's an MFJ-1835 Cobweb antenna, and it covers 20, 17, 15, 12, and 10 meters. The one that particularly interests me is 20 meters because that band is still quite open during the daytime, and sometimes in the early evening you can do some pretty spectacular things with it. And during contests, all the bands are open. Plus, with the sporadic E these days, it's very possible there could be some interesting 10-meter openings. So this antenna strikes a chord for those who have very limited space. If you've got the problem of very little space, like this thing only takes about 10 feet square, this antenna might do a very good job for you. It's about, like I said, 10 feet square, flat. You want to get it up on a pole at least 10 feet. And given that that was the use case, kind of we're going after is a stealth type of an antenna, I actually mounted it about 9 or 10 feet in the air. Okay, so it's pretty close to the ground. Yet it actually does really well. I'm impressed with this antenna. It's made by folding up 5 connected dipoles. So let me show you in this little brief video outtake how you can take those folded up cobwebbed dipoles and unfold them so that you can see that they are actually essentially full-length dipoles for 20 through 10, 5 of them connected together. If we unfold it, okay, like this, and this goes right out of the field of view, doesn't it? Way over to here, what we see as we go across and back and forth is we see that it's actually quite long, okay? Right like that. Now, let's take the next one, okay? And then this next one, okay, now what we're interested in is this line right here. So, if we were to continue going around now, like that, okay, this is one side, the other side does exactly the same thing, okay? So we have a common feed point, 20 meter antenna here, goes all the way out here. Okay, and a little longer, and of course the 20 meters all the way out to there. So what we see, this is the equivalent of taking dipoles for 10, 12, 15, 17, 20, connecting them together at one point, and then stretching them out in parallel where they're next to each other. Okay? Kind of next to you. This is a fairly standard way. In fact, I can show you in the ARRL antenna handbook a very similar type of thing, and there was these are actually sold. You can get them, and they'll have little things that hang these together, the 20 meters all the way there. They all come together at a little black box. The black box has a balun in it. Okay, it's not just a straight through connection. The antenna claims horizontal polarization. I suspect it twists a bit when you go off to the side, so you get a little bit vertical here and there. It claims omnidirectional. I have no way in particular to test that, but then again, I have nothing that contradicts that. Let's move to the unboxing. I love unboxings. It's just like Christmas. This is me standing next to the big box. The big box is over 6 feet long, okay, and very sturdily packaged. This is packaged in double thickness cardboard. This is the summer of antennas. I'm looking at solutions for those who live in covenant-controlled communities, apartments, and other places where their space for antennas is limited. Shall we begin? Yes, we shall. Okay, so this is the monster box. Let's see what we can do here. It's 6 feet long, and it is held in place by those horrible staples. Pardon me while I stand up. There's one. I'm assuming it's an antenna in here. It might be a rose with a very long stem. Perhaps it's the new civilian bazooka the Defense Department's been putting out. Maybe it's a poplar tree. Okay, now we've got the staples out, but the ends are kind of taped down, so let's untape them. I don't know, let's see, the opposite of taped down would be taped up, is that right? That's just padding, the whole thing. Okay, parts. Here's something really bundled up. Here's some mechanical pieces, including the clamps, the different little pieces of hardware used to separate the far ends. Here's a clamp piece made of aluminum. Here are some resonant parts made of what looks like stranded tinned wire. That's for 12 meters, 10 meters, 20 meters, 13 meters, 17 meters, and 15 meters. Here is 2 plates. They're going to go like this, and the poles will go in there. And then let's look at what's in the side. We have one shorty. That's the thing the feed goes on. And then we have these are all the same length. You see, these are plastic, it appears, but boy, that is a strong, very strong plastic. I think it said fiberglass in the literature. We'll find that out in a hurry. Then there is the instruction manual. Something about how the saddle bolts are supposed to be done. And then these are the things that are insulators that go at the far ends. So let's get that out of the way. That's light. Okay. Now we gotta look and see what's inside here. This is the mystery piece, the part that does the secret work. And this is the magic box that does the balancing. And it's got 4 little black screws here on the end, and then this thing which just holds it to this rod. And then all of the wires from these various points will loop to these. So you've got every single antenna tied to it, of the 5 antennas. And this has got some holes drilled in the bottom. It's obviously designed to be pointed down so the rain won't get in it. And yes, we will be taking it apart to see what's inside. Okay, this bag here is full of... Remember when I was doing a video on kit building, I says there are a lot of things that are not called kits, but actually they are. And this is a very good example of that. It's an antenna. It's not sold as a kit, but that's exactly what it is. And all these parts and pieces and doodads and thingies that go here and there and hither and yon and so on. So these antenna elements are, there's 2 in each bag, because you've got one half coming out here and the other half coming out here. So, next step, assemble it. I'm going to give you a little bit different order for doing it that I think will make things a lot easier. The basic little hardware thing for assembly is a screw, sometimes a washer, and a bolt that has some plastic in it that will bite down onto the shaft of the bolt. I'm sorry, they're nuts that have the plastic in them, and they will stay in place very, very definitively. They don't move. So construction is easy, but will require patience. Now, I would suggest that instead of adding the bolts for the wires as you put the wires on, you put the bolts all in place before you even assemble the cross pieces. Just put the bolt through with the washer and then get that weird plastic nut started enough that it won't come off. That will make it so much easier when you pull the wires taut, because the hardware is already in place. Okay, so when you have these in place here, then you won't be losing them out in the grass. Now, when adding wires, pull the wire up to the screw. Barely just any tension on the wire. You want the wire to be just a little bit loose. Screw that screw tight, and then that washer will hold that wire in place. And then that way you can go on to the next without worrying about that falling off on you. It works a lot better that way than trying to install those washers as you're moving the wires. Now, I do have one caution for you based on experience. Do not let one of the wires get tangled up. I let go of one, and it was a heck of a job to get that thing untangled again. But rather, as you put it on, carefully unroll it so that you get where you need to go. Don't kink the wire. If it looks like it's a kink, back it off and unkink it for strength reasons. Okay, you're all going to start with the ballon in the middle, the little black box that's a ballon. Now, I was kind of under the impression, since you need to add a coax ballon later when you put this thing up, that what was inside was going to be just a straight connect through. So I took it apart to take a look, and sure enough, it is a ballon that's in there. I don't believe that you should rely on that as your total ballon, but go ahead and put in the coax ballon as indicated in the instructions, which I did. Okay, don't pull up too much slack on there so you get the thing bent all over everywhere. Here's the ballon. I've been doing some work. I had a real problem with these screws. As I tightened them on the outside, I ended up loosening them on the inside, so I had to do some surgery there. I really recommend taking a look at that, because if that comes loose on you, the antenna is not going to perform. The antenna here is assembled to the point of the arms are out, and I've now put on most of the little pieces of wire, which are almost invisible here. You see little parts of them as they come down to their little screw posts there. Those screws have got a washer under them and then a locking nut on the bottom, so it holds that pretty firmly in place there, so it won't flap all around. That in the middle there is the ballon, which everything comes to. So very shortly here I'll have the whole thing constructed. Alright, here's the completed antenna, ready to go up. It's upside down right at the moment. It will go the other way, and you can see the reflections of the wires. So the job at this point will be to put it up about 10 feet off the ground, measure SWR, resonant frequencies and things like that on every band, and then come out here and make an adjustment. And we'll do 2 or 3 rounds of that. Well, there it is. It's out on the testing stand where I had the loop before. It's about 9 feet in the air, something like that. For initial testing, you can see the coax rolled up there. That takes quite a bit of coax, about 18 feet, to give the 12 turns a 6-inch ratio. And it has not yet been tuned, so it is in the position to be tuned, but I need to come up with a few feet more coax. Coax loop actually takes lots of coax. When you multiply all of that out, it's almost 18 feet of coax that goes into that loop. 18 feet. Okay, so be prepared for that. I don't know why they have this. When you do the loop of the coax, it's a balun, okay, and it creates, or rather, keeps common mode currents coming back along the outside of the coax shield. It stops them, but there's also the balun that's inside. So I don't know. Seems to me like we've got two. I constructed it exactly as it said to construct it. It works great. Okay, now there are many little pieces of hardware that you can see in this picture that I ended up not needing. And I'm sure under certain circumstances they would. Now, for testing, I've just got the end pieces folded back on themselves and wrapped. They do give you some screws you can put down on that so you can make that a little more permanent so a hurricane can come through and not pull those out of there. Up to you. The biggest problem that would cause a problem with those things wrapped back on the end would be an ice storm or something that would tend to really pull on that wire and could pull it loose. I do not recommend soldering there because when you move it from your ground testing position to up on the roof or somewhere else, it's going to change tune slightly. Now, with regard to the tuning, you've got basically 5 dipoles. And when you tune one, you affect the other 4. So there is no written protocol for how to tune this thing, for which band to tune first or last or anything like that. The answer to that is you're just going to have to get used to the idea that it will take several iterations. You'll tune the 20 meter on the outside, and you've got these little holes in the insulator, and you can kind of count holes and so on and move things back and forth as you go. But you do them in order, and you go check out with your antenna analyzer to see where the resonant parts are, and then you keep tweaking in very small amounts until you get it just the way you like it. It will cover the entire voice or CW, but not both, section of all those bands. Okay, the 2 bands, 17 and 12, are fairly narrow, so it covers most of them, but it doesn't cover very much of the 10 meter band. So I set mine to cover the novice portion because frankly that's where the action is on 10 meters. 28.3 megahertz to 28.5 megahertz is where you'll see a lot of voice activity when the band does open up. But it's nice that it covers the entire voice portion of the 20 meter band, and you can tweak them with a tremendous degree of tightness. Now, one thing I want to warn is that all those insulators need to line up, because if you put one of the insulators to the side, it means this wire around is longer than this one, so you're in essence feeding that dipole off center, and that will introduce reactance. And you don't want reactance in there because it hurts the SWR. You may find if you get down to, say, SWR and it's 1.3 and you just can't get lower, check and see if that centerpiece that holds the 2 ends together is maybe a little bit to one side or the other, and try centering that a little bit more. You may be able to get a better SWR. Your goal is a 2-to-1 SWR bandwidth that covers the areas where you want to operate. Okay, now tuning does require taking down the antenna. Unwinding and rewinding of that fine stranded wire can be a little bit of a pain, and you can tie them down with the screws. Okay, so again, because it's a multi-band antenna and so many things are going on here, it's not super broadband. Okay, testing. I tested it the way I usually try to test an antenna. I didn't really do any comparisons. It's not as good as my vertical. My vertical's really for what it needs to be, is a full-size multi-band vertical. It's an excellent vertical. It's got lots and lots and lots of radials. I really like it. This antenna is not as good as that, but it is a compromise antenna, and if you have limited space, I had people answering my CQs. You can also pump a fair amount of power into it if you get the H version, which handles the high power, which I did. So you can put more power into that if you want. But with 100 watts, I was able to get people to answer my CQs. I had a number of very satisfactory QSOs with, I think, Arizona and California and places like that. So, in conclusion, we've got to conclude here at some point, right? I wish it had 40 meters. There's not much action on 17, 15, 12, and 10. There's a lot of action on 20 and a lot of action on 40. But that would have made the thing very large. Very large. So we can't do that. Now, as far as looks, it looks, frankly, it's supposed to look like a cobweb. From a distance, it looks like a clothesline. And in fact, we were thinking of maybe hanging some unmentionables from it for drying out this. Also, if you were to throw a thin cloth over the top of it, you could call it a canopy and put some chairs and a table under it. You could disguise it as most anything. My wife thinks it's not nearly as interesting as the 1788, which is a loop, makes a pretty bold statement. But this you're looking end on horizontally. It works well for its assigned use case, which is limited space antenna where you can get outdoors. They talk in there about how they throw in lots of extra parts. They really did. I didn't use all the extra parts that were in there. I really like this antenna. I think I'm going to put it up on my roof just to give it a little more height. I know that's not its standard use case, but it's a good antenna. I've enjoyed it. It's not anywhere near as noisy as my vertical, so that's a bonus. You can hear some of the faint stations better. So, do I recommend this? Yes, I absolutely do. Caveat, did I pay for this? Nope, MFJ sent it to me. I specifically requested that one because I'm on this crusade to help people with limited space or apartments or whatever figure out ways to get on HF, and this looks like a good one. You know, I want to talk to you about something called Patreon. If you go to patreon.com/KE0OG, you'll find the Patreon page. That's for those who would like to make a recurring tip. You know, instead of, say, a $10 tip once in a while, could do a $10 tip every month or something like that. In the meantime, please use both feet when walking. Check out the tip jar, and we'll talk to you next time, 73.